welcome to another Dr. Z video. Today, again in accordance with the Cambridge Science textbook, we are focusing on electric fields. As always, don't forget to comment on anything you are struggling with at school so that our team can help. Alright, so here are today's outcomes. Some of you may be familiar with it, some may not. Let's get straight into it. So the first thing we have to do is identify the components of an atom and basic atomic structure. So I'm sure we've all experienced static electricity before, whether it be removing a jumper or that sensation of tingling. But in order to understand the nature of these electrostatic forces, we must first have a solid understanding of the components and the structure of an atom. All the atoms on the periodic table, from hydrogen to bismuth, are made from three kinds of subatomic particles: protons, neutrons, and electrons. Now, of these subatomic particles, two of them carry an electric charge. Protons carry a positive charge, whereas electrons carry a negative charge. Whilst neutrons are neutral and have no net charge. But what exactly is the structure of an atom? The diagram on the left is a useful aid for you to note. So, firstly, in the center of the atom, which is known as a nucleus, there are protons and neutrons. Protons and neutrons each have the same mass of approximately 1 atomic mass unit, and therefore virtually make up all the mass of the atoms. Electrons, which are 1835 times more smaller than a proton, are clearly more lightweight and don't contribute to the atomic mass. Instead, however, these electrons exist in a cloud orbiting in the nucleus, known as electron shells. Remember that in uncharged neutral atoms, the number of protons is equal to the number of electrons. So as you can see in this diagram, here is the nucleus, and here are the electron orbits. Alright, but how exactly do objects become charged? Now, any material that has more protons than electrons is said to be positively charged, and if it has more electrons than protons, it's described as negatively charged. But again, how do they become charged? Well, this is generally due to the addition or removal of electrons, and this is crucial for your understanding. So, the charge is termed electrostatic because once an object gains a charge, it remains stationary on that object. Only in materials like metal, for example, which are known as conductors, do charges move through the object, creating a current rather than static charge. Now, there are two ways an object becomes charged, and again, the diagrams on the right are a useful aid for you to see. Firstly, charging by friction. So, charging by friction refers to if you rub one material with another, electrons have a tendency to be transferred from one material to the other. For example, if you rub glass with silk, that leaves the glass with a positive charge. Or a plastic ruler with wool, for example, means that the electrons from the atoms on the surface of the neutral wool are forced onto the neutral plastic ruler. There is also charging by contact. If a neutral material is touched by a charged object, electrons can be transferred from atoms on the surfaces of the two objects. When the charged object is removed, the originally neutral material will now be charged itself, as it has gained or lost electrons. Now, let's talk about electric fields. Now, as you all know, and you should know, a charged object can attract or repel other charged objects near it. Remember, like charges repel, whilst opposites attract. Now, think of a magnet. When you use a magnet, these pushing and pulling forces, or the forces of attraction and repulsion, don't rely on contact. Like magnets don't need to be touching each other to exert a force on each other. Similarly, electric forces can justify electrostatic forces without contact. The area around a charged object is known as the electric field. Now, you are required to sketch electric fields, and there are 4 golden rules which you must remember. The diagrams on the left are very useful, so I suggest you to take a note and perhaps even copy these diagrams to see how exactly it works. Firstly, Electric field lines always extend away from a positively charged object and towards a negatively charged object. So take this diagram, which shows positively charged objects. You can see that the arrows are extending away from it, so they're pointing away from it. Now take this one, which is showing a negatively charged object. It's clear here that the arrows are pointing towards this negatively charged object. Now, arrows are used to show the direction of the field lines. You can see in all 7 of these diagrams, there's only arrows being used, not lines, not anything else but arrows. Now, electric field lines never cross or intersect each other. If you look closely at these diagrams, not one is overlapping or intersecting with one another. Not one. That's how you have to draw electric field lines, because if you do cross or intersect each other, you do lose marks. Remember that fulfilling these 4 golden rules gets you marks in your examination paper. And finally, electric field lines are most dense around objects with the greatest amount of charge. You can see that the electric field lines are very close together in object C compared to object A, and therefore it is clear that object C has the greatest amount of charge compared to greater amount of charge compared to object A and object B. And finally, let's talk about everyday phenomena where electrostatic forces are involved. So the most common one is lightning. Now, lightning, and let's explain the process of what exactly occurs during lightning. So particles of water and ice inside clouds are constantly moving against each other, which causes, as we've identified earlier, the buildup of charge. Like moving against each other creates this idea of friction. Now, some of parts of the cloud become negative due to the constant moving against each other, whilst others become positive. The charges keep building up. Eventually, the charge accumulated is so great that it quickly discharges to a nearby cloud or to the ground. The result is a spectacular spark we call lightning, as you can see here. Now, lightning has devastating effects, but it also does take the easiest path to ground. Hence, on top of melting buildings, there are lightning rods, as you can see here, which are most likely to be struck and therefore keep the rest of the buildings safe. Okay, that's all for today, and I hope you enjoyed the video. Please like and subscribe, and thank you for watching.